And we are now live. Now, by the way, somebody in my other class told me that this one's out of focus. Have you guys noticed that?
Yeah, a little bit.
It's funny because it's the exact same camera. Well, it looks like it's kind of going in and out of focus. What's the other class? It's always in focus. The problem is the other class, I've got like so little board to write on, I have to erase it right after I write it. But anyway, we're going to finish off 3.6, which is rational functions. And what we're going to talk about is exceptions to the rule about asymptotes. Okay? And so when I am going to say rule number one, and this isn't an exception, but it is kind of, okay? You will never, and I'm going to underline the word never, cross a vertical asymptote. But, here's your big but, okay? But you can have a hole if you have the same factor in the numerator and the denominator. Okay? So we'll give you an example of something like that. Okay? So you will never actually cross, but you can have a hole. Okay? The other rule is you can cross a horizontal or an oblique asymptote. Okay? And maybe instead of can cross, it's possible. It's possible to cross a horizontal or an oblique asymptote. Okay? And so basically, the way to check is to set the asymptote equal to the function. Okay? And if you get a valid answer, it crosses. Otherwise, you get a false statement. Okay? So I will give you a couple of examples. Well, maybe, should I just do some?
Yeah.
Should we just do some and then you'll kind of see? All right, let's do a couple examples here. Okay, let's see here. What if we have r of x equals 3x squared minus 2x minus 1 over 2x squared plus 3x minus 2. Okay? All right. I'm going to pick my black. I think it's easier to see, especially on the video. All right, so let's pick on Daniel. What would you do first? I told you I wanted you to graph this.
When trying to graph it,
So I want you to graph this function. What would you do first? Find the domain. How do we find the domain?
Whatever. Let's see. Well, we're gonna have to factor
Factor what?
the denominator.
Factor the denominator. Okay, so let's factor that. That factors into Factors of 2x squared are
2x.
2x and
2x.
x,
Or x.
just plain old x. Okay. Factors of 2,
1 and 2.
1 and 2. So if I go 1 and 2, that gives me 4x and x, and I can get a 3 if I get my signs right, right? So how does that work? Negative 1, positive 2. So that's positive 4 minus 1 is 3. Negative times a positive is a negative. That works, right? Okay? So your domain is what?
It's negative 2.
X cannot equal negative 2, or
It can equal
1/2. Okay? I'm going to start drawing this. Okay? 1/2 is going to be about right here. And negative 2, 1, 2. Okay? All right, now, let's see. On vertical asymptotes, it will never cross, but we need to see if it can have a hole. So how would we check, Michael, if it has a hole?
Is it the horizontal asymptote equals the equation? Like, so you would take.
No. That's where it can cross. And the hole is if you have
Oh. If you have the
same factor in the numerator and the denominator. So we need to factor our numerator, right? Because we got to see if one of those factors is the same. Okay? So how do you factor the numerator?
Well,
It's really hard to see what that is. For those of you who are watching at home, kind of goes in and out of focus, doesn't it? Doesn't matter. Okay? So we're going to factor the numerator into 3x and x, and factors of 1, 1 and 1.
But it's plus in between 3x
Plus
and minus.
and minus. So that gives me a positive, no, negative 3 plus 1 is negative 2. Positive times a negative is a negative. Okay? So, what do you think? So there's no holes. Okay, that's good. Okay? All right, so we got no holes, but we want to see if it's possible to cross. And so, Holly, how would you do that?
I actually have a question. Can you explain the concept of no holes?
Of a hole?
Yeah.
Okay, so if I did have a hole, I would have the same factor in top and bottom. So let's change this one to, so if I had x plus 2 on the top and x plus 2 on the bottom, that would be a hole. And so if I did have a hole, I would have a hole at negative 2. Okay, so the easiest thing to do, let's pretend this factors into these two. We're going to ignore that for a minute. I would cancel those, and I would be left with this over this. Okay, so I would find r of negative 2, and then wherever that was, well, let's just do it really quick. 3 times negative 2 plus 1 over 2 times negative 2 minus 1. So that would be negative 6 plus 1 over negative 4 minus 1. And so that would be negative 5 over negative 5, which equals 1. Okay? So what that says is, if I had the same factor, which we're calling x plus 2 here, okay? I would, in fact, this is where I differ from the book just a little bit. I think it's better if you say, oh, I've got an asymptote here. The book would say that asymptote's not really there. But you do know that your domain is x cannot equal negative 2. Well, my simplified fraction with this missing, at negative 2, where the asymptote would be, I have a hole at 1. So I would draw a hole. Okay? Now, it's up to you. The book would not call this an asymptote. What it would do, it would just erase that completely. And let's say that it went something like this. It might look something like that. So you'd have a hole where the asymptote should have been. Okay? And so that's how you do that, okay? But of course, we don't have that problem. So I'm going to put that asymptote back in where it belongs. And that's not a factor. And this is the problem we're dealing with, okay? All right, so you'll be really good at the next problem then, right? All right, so what do we do next?
Are you gonna set your asymptote to a function?
Well, we need to find our horizontal asymptote first, right?
Uh,
Horizontal or our oblique. So do we have one?
And you look at the degree,
Look at the degree of the numerator, which is
2,
2 over
2.
2. And so since they're the same,
You look at the leading.
I just need to look at these leading terms. And so therefore, I'm going to get y equals 3x squared over 2x squared. The x squared cancel, and I'm going to have a horizontal asymptote, which is my range as well, right? Which is what?
3.
Now, 3/2 is only halfway correct.
What do you?
You need to say
Oh,
y.
equals, yeah.
Y does not equal 3/2.
Y is not equal to
Yeah. Okay, so y does not equal 3/2. I've got another asymptote here. Okay, so now that we found all of our asymptotes, that's probably the first thing you're going to want to do. We do not have a hole, but we do need to check and see if we can cross. Okay, now just so you know, if I am going to cross, it's probably going to be in this region. And then the asymptote is going to apply in these two regions, okay? So the asymptote implies in the extremes. It might not apply when you're close to 0. Does that make sense? Okay, so let's see if it crosses. So how do you do that, Demi?
set asymptote to a function.
Okay, so we're going to set this, even though y can equal 3/2, we're going to set it equal to 3/2. 3/2 equals what?
3x squared minus 2x minus 1
Over
2x squared
plus 3x minus 2. Okay, so how do we solve that?
We can multiply the bottom.
Yeah, let's actually just cross multiply.
Okay.
Okay, so if we cross multiply, this becomes 6x squared plus 9x minus 6 equals 6x squared minus 4x minus 2. Okay, so my 6x squared are going to cancel, right?
Mhm.
And then what?
Would you like add 6 to the other side?
Add 6 to the other side and add 4x, right?
Yeah.
So the 6's go away, the 4x's go away. I'm left with 13x equals
8.
4, negative 2 plus 6. Okay?
Oh, maybe
Yep. And then I'm going to divide by
13.
13. So I got an answer, x equals 4/13. What does that mean? Did I get a valid answer?
No.
Yes, I did.
Oh.
I got a valid answer, so therefore it crosses. If I had gotten, for example, 5 equals 6, is that a valid answer? No. So if I got 5 equals 6, would it cross? No. But in our case, we cross where x equals 4/13 and y equals 3/2. Okay? So at 4/13, that's about 1/4. So x is about 1/4 and y is 1.5. So it's going to cross about right there. Okay? Now the question is, does it go this way or does it go that way? Now, let's go back to our original equation. If I set x equal to 0, those terms all drop out, right? And so what's left?
The
Negative 1 over negative 2, which is 1/2. So if x is 0, y is 1/2. Okay, so I've got 2 points here. So it's probably going to go up like that, right? And now, if y equals 0, so if I said this whole thing equals 0, 0 equals 3x squared minus 2x minus 1 over 2x squared plus 3x minus 2. How do I solve that, Rory? Divide? Multiply by the denominator, that's just going to go away, right? And then this factors into that, right? So I'm going to have 3x plus 1 equals 0 or x minus 1 equals 0. So x equals,
Yes.
3x equals negative 1, x equals negative 1/3, right? And if I add 1 here, x equals 1. So I've got x equals 1, y equals 0. So I've got x equals 1, y equals 0. And if x equals negative 1/3, y also equals 0. So it's about right there. So now I've got a pretty good idea what goes on in this middle section, right? It's going to go something like that. I also know that I've got an intercept here. So it's probably going to go like that. What's going to go on over here? Nathan, Gardner?
It's gonna go there.
It's going to go where? I could either plug in a -4, but I know we don't have an intercept, right?
Yeah.
So if I know, if we found all the intercepts already,
Oh.
it's going to go here. But if you're not sure, do what you just said, plug in -4, and then you'll find out that's where it is. Okay, does that make sense? Okay. All right, so this one didn't have a hole, but it did cross, okay? So essentially what we're saying is the asymptote applies in this area, it does not apply in this area. Okay? The horizontal. More fun than you ever wanted to have? Okay, should we do another? All right, let's see if I can find a good one.
Okay, I have a question. Where did you graph the hole, the 436?
Where do they graph the hole?
Yeah.
There's no hole.
There's no hole. Okay, so then you don't have to graph the 436 at all?
So 4/13?
Yeah.
Okay, it's not a hole, it's an actual point. It crosses that asymptote at 4/13, 3/2. So that's 4/13, and that's 3/2.
Okay, wait. Show me how you graph that one more time. 4/13.
Okay, so
I see.
remember we have in a horizontal. There we go.
Yeah.
You good? Okay. All right, so here's another one. How about, let's go back over here. Okay, you've got your exceptions to the rule here. I'm going to erase them. Plus, I think it's pretty hard to read with that light purple marker. All right. How about if I have s sub x equals x minus 3 over x squared minus 3x. So, Riley, must be your turn. How would you start this one? Domain, and the domain is? How do you find the domain? What do you got to look at? You got to look at the bottom. That cannot equal what? 0. So how would you solve that? If if it were to equal 0? You would factor that, and that would factor into x times x minus 3, right? Okay, so your domain is what? X cannot equal 3 or 0, right? X cannot equal 0. Okay, does that make sense? Okay, Joey, what's next? So you've got vertical asymptotes there, right?
We want to find the horizontal ones.
We need to find our horizontal asymptotes. So I'm going to put this on here. 1, 2, 3, and 0. Okay? Now, horizontal asymptotes. Horizontal or oblique, right? How do you find those?
So the top degree is 0. Oh, no, sorry, 1, and the bottom is 2. Right?
Okay,
Is that right?
that's correct.
So is that 0? So it's smaller?
What's 0?
The horizontal.
And what do you call the horizontal?
Y not.
Y cannot equal 0. Okay?
Right?
So we've got another asymptote here. Okay? Now, we need to see if we can cross or if there's a hole. How do you do that, Tyler? Yeah, it was those two rules that I just erased. You have them written down on your paper? You didn't write them down? Oh, that was bad. How are you supposed to refer back to your notes if you don't write them down? Okay, Cameron, do you remember? Did you write them down? How do you know if it crosses?
I did not finish it.
Oh, you didn't finish writing them down either? Javier's got it.
So they're the same factor in the numerator and denominator?
If they're the same factor in the numerator and the denominator, what do you have? A hole. You need to write that down. Okay? If you have the same factor, do we have the same factor in the numerator and the denominator? We do, right? That would cancel that, right? So therefore, I have a hole where? At 3, okay? So if I simplify this, I need to find s of 3 with the simplified fraction, right? S of 3 is, if this is just 1 over x now, right? 1 over 3. Okay? So I've got a hole where? Where's my hole?
3 and 1.
3 1/3. Now, here's where I'm a little bit different than the book. I would like you to draw those asymptotes right off the bat. Okay? The book would say there's not actually an asymptote here. Okay? But there's a hole, and we know that the hole is where x equals 3 and y equals 1/3. There's a hole right there. Okay? Now, I'm perfectly fine with leaving that asymptote there, but the book would say there's not an asymptote there. Whatever it takes, just remember you got a hole right there. Okay? Does that make sense? Yes. Okay, so I took, remember this was, so the function s of x equals x minus 3 over x times x minus 3, right? So if I simplify that, that becomes 1 over x. Okay? Now, because I've got the same factor on top and bottom, I'm going to plug in that number, see if there's a hole there. So I'm going to do s of 3 of this simplified fraction. Does that make sense? Which would just be 1 over 3, right? Okay, so that's how I got 1/3. Okay? All right, so I know I've got a hole here. Do I cross this axis, this asymptote? Yes.
I just don't think I understand what a hole means. Like, does it just mean it deletes the asymptote? Is it real, or is it like the only spot through the asymptote?
Well, I'm gonna answer that as we finish graphing that, okay? No, but I do wanna say, do we know if it crosses the horizontal asymptote? How do we check? What was the other rule? Who wrote it down?
Set the horizontal asymptote equals the equation.
Okay, so we're gonna take this equation here, we're gonna have 0 equals x minus 3 over x squared minus 3x, right?
Yeah.
I'm gonna multiply both sides by that, so that's gonna go away. I'm gonna get 0 equals x minus 3, and I'm gonna add 3, and I get x equals 3. So at x equals 3, y equals 0. Is that right? No, you know what, that's not right. Here we're going to take the simplified fraction. Okay? We're going to take this here. We're going to set our horizontal asymptote y equals 0 equals 1 over x. I'm going to multiply both sides by x, and I get 0 equals 1. Is that a true statement? Only when I owe you money. Okay? All right, so that's a false statement. So does it cross the horizontal? No. Okay? So to answer Joey's question, if I'm not sure what happens, I'm going to just plot some points. But basically what's going to happen here is I know it doesn't cross the horizontal. I've got a hole here. Now over here, I have to just pick a negative number. Any negative number will do. Let's pick s of -1. That's going to give me -1 minus 3 over -1 squared minus 3 times -1. -1 minus 3 is -4. 1 plus 3 equals -4 over 4, which equals -1. Okay, so at +1, I'm at -1. I know I'm here. I don't cross, and it's going to look like that. Okay. All right. So quiz tomorrow is on the rest of 3.6. And then we're going to have a review that I hope post later tonight, but we'll be before class tomorrow at the latest.
Is the test on everything from 2.1 to now? Or is it
So,
on?
yeah, remember that whichever problem you missed on your last test is probably going to be on this test.
Okay.
So study all the ones you missed. How do I turn this off?
So like for the test, he wants to delete the asymptote right there and leave the hole.
I don't care. I would leave the asymptote there as long as you know there's a hole there. The book deletes it, but I would leave it there personally.
Okay.